Hi, good morning my dear students. I'm Daphne Cole. Welcome to my STPM Chemistry discussions. Dear students, what separates alcohol and vinegar is just a fine line. Of course, our taste bud could tell us an alcohol from a vinegar. But how do we know chemically the difference between these two liquids? Today, I'm going to discuss about the reactive acidity of alcohol, phenol, and carboxylic acid. Now, let's go to the first part, the acidity of organic compounds. Dear students, recall from the topic of ionic equilibria in semester 1, we learned how to determine the pH value of the solutions. We may calculate the pKa value and compare the strength of acid. Without knowing the pKa value of the solutions, we may determine the reactive strength of two acids. We may compare the stability of their conjugate bases. There are three parts here. Part 1, and this is the example of past year questions. Then part 2 and part 3. In this video, we will discuss part 1. It is related to the reactions of organic acid with metal, alkalis, and carbonates. Dear students, acidity of organic compounds, especially alcohol, phenol, and carboxylic acid, and explanations of their reactive acidity is part of the STPM or A-level chemistry syllabus. Now, let's look at part 1, reactive acidity of alcohol, phenol, and carboxylic acid with metal, alkalis, and carbonate. In this video, we only focus on the reactive acidity of carboxylic acid, phenol, and alcohol. Before comparing their acidity, let's look on the chemical property of acid first. We must always remember that alcohol is a weaker acid than water, so alcohol only can react with metal. Phenol can react with metal and sodium hydroxide. Carboxylic acid is the strongest acid and can react with sodium hydroxide, and sodium carbonate. At first, we need to know the functional group of 2-hydroxyl benzoic acid. It has functional group of carboxylic acid and phenol. If we refer to this table, both carboxylic acid and phenol will react with sodium hydroxide solutions. Therefore, the salt produced from 2-hydroxyl benzoic acid with sodium hydroxide solution should be like this. Next, when 2-hydroxyl benzoic acid reacts with sodium carbonate, only the functional group of carboxylic acid will show reactions. Now, let's see what are the functional group in compound Y. Phenol and alcohol.